So hello students, how are you? So as you can see that digital classes are going on as well as Verilog classes are going on free of the cost. So we can upload up to like 5 hour or 6 hour classes, like 10 classes we can upload you on our application free of the cost. But if you want the complete recording of these classes, you have to purchase the whole course, in which you will get the multiple recordings as well as live sessions as well as doubt clear sessions, assignment, quizzes. Everything will be given in a structured manner. So you can download our VLSI for all application. There you can purchase the courses. If you have any queries, go to the website, go to the free counseling session. We will suggest you which course you have to purchase and what will be the content. If you have any query, feel free to contact us, or you can directly WhatsApp to me. Here is my WhatsApp number. It's 9643 070 368. You just have to drop your message. Within 2 or 3 days, I will going to call you. Within 2 or 3 days, I will going to call you and discuss the things what we are covering in this. In the application, you will get the pre-recorded sessions as well as the live sessions will be also there. So that will be also there. Fine. So it will be completely structured with the placement assistance. Fine. So yeah, Shipra ma'am, you want to say something? So we can upload, like, we have the limited resources, right? We can't upload all the free classes. So yeah, ma'am, what are you teaching today?
So I am teaching digital electronics question on sequential circuits.
Yeah, sequential circuit, right? Yeah. Okay, ma'am, you can continue now. Thank you.
Sure. Okay, thank you, Rajat. Okay, moving on to the next question. So the question says that in the latch circuit shown, the NAND gate have non-zero but unequal propagation delays. Okay, they are saying that there are two. This is a latch circuit, right? The latch is the basic sequential circuit which we make. After latch only, we in order to stabilize the latch outputs, we make flip-flops. Okay, so this is a NAND gate latch. They are saying that both the NAND gates in this have propagation delay but may not be equal. The present input conditions of P and Q are 0, 0. So present inputs were P and Q both are equal to 0, and this condition has changed to what? P and Q are equal to 1. So this is changed. Now they are asking that what will be the output X and Y. So this is what they are asking. Now this is a NAND. So if I draw the truth table for NAND, X input AB and output Y. So 0, 0 is 1, 0, 1 is 0, 1, 0 is 0, and 1, 1 is also 0. So this is how NAND look like, just opposite for AND, just opposite of AND gate. So this is the truth table for NAND gate. Now you can see that if the inputs P and Q are 0 and 0, so if we see any of the input of NAND, it will be equal to 1. If it is equals to 1, then the output, it's short, it is equals to 0, right? But if it is equals to, this is not the truth table for NAND, this is truth table for NOR. Okay, let me draw it again. A and B are the input and Y is the output. 0, 0, 0, 1, 1, 0, and 1, 1. So it is 1, 1, 1, and 0. Now this is opposite of AND gate. I'm sorry, my bad. I need to correct it. Now what is there? If any of the input, this is NAND. Okay, if any of the input in NAND, if it is equal to 0, the output will be equal to 1. If any input is equals to 0, the output will be equal to 1. Only one special case, the output is equals to 0. that will be equal to 0, right? If this is a 0, this is 0, no matter, it does not care, no matter what the next input is, this x is going to be 1. And similarly, if this q is equals to 0, doesn't matter that the next input is what, it is going to be 1. So we know if p and q are equal to 0, x and y will be equal to 1. But they are saying p and q is equal to 0 and the situation is changed to p and q equal to 1. So now in this case, what is going to happen? Instead of 0, 0, the output, the values of p and q are equal to 1 and 1. Now in this case, both 1 and 1, that can be any possibility. If any of the input is 1, the output may or may not be 0 or 1. Okay, both are the cases. So that depends on what? The other input, the next input. Suppose this value y is equals to 0, the output will become 0. The other input to this gate, the gate number 1, will become 0. So 1 and 0, output will become 1. Here 1 will go here and 1 1 will be equal to 0. So this is a stable output, right? The output is stable since we have assumed it to be 0, and according to our circuit, the output given by this circuit is also 0. So our assumption is correct and this is a stable case. If we case another case, if we take it as 1, so instead of this 0, if I am taking it a 1, this will be 1. 1 and 1 will be equal to 0, right? And there 0, 1 and 1 will be equal to 0, and here 0 will be carried here. This 0, 0 and 0 will be equal to 1. This is also true, right? Both the cases are stable. So either x is equals to 1 or y is equals to 0, or x is equals to 0, y is equals to 1. This case is true. Either of the situation is true. You got my point? We have assumed it to be 0 first, and if we have taken it 0, the assumption output is coming out 0 only. And if we take it equal to 1, the assumption output, if we assume it to be 1, the output will be also become equal to 1. Correct? So this is how we solve these latches question. We assume it depending on the type of latch, if it is a NAND or not. We know certain things about NAND. So NAND is, if for NAND gate, if any one input is equals to 1, then output is certainly equal to 0. And this is opposite for NOR. In NOR, I have previous table I draw by mistake was NOR table. If any one input is equals to 0, then output is equals to 0. If any input is equals to 0, then output is equals to 0. So that will be for NOR table. Now, moving on to the next question. So next question. Okay, next question says that there is a D latch given here. D latch is shown in the figure with a which is transparent. Transparent means basically this is D latch. Okay, transparent means D latch. When D value, this is output. Transparent means this. Okay, whenever D value is 0, output value is 0. Whenever D value is 1, output value is also equals to 1. So that is what transparent means. Okay, when its clock input CK is high and has a 0 propagation delay. Right, in this figure, clock signal CLK1 has 50% duty cycle and CLK2 is 1/5 period delay of clock 1. The duty cycle of the output latch in the percentages. Now you have to find out the duty cycle. Duty cycle, I have told you that duty cycle is the amount of time it is on as compared to the total time period, right? This is how we calculate the duty cycle. Now in this circuit, if you see, so this is your clock 1 and this is clock 2. So clock 1 is applied here, clock 2 is applied here, and clock 2 is delayed by clock 1 by t clock by 5. I am extending it and I will be giving you the output of, I don't think there will be some scaling option like tools. No, I don't think that there will be some tool like that. It's okay. I will try to draw lines more fine. Okay. Okay, clear. So this is your T clock. So this is your half T clock, half cycle. T clock by 2. This is also T clock by 2. Now this is what D should be when both are 1. If I am drawing there D, this is 1, this is 0. The output given by D latch will be equal to 0. This is 1 here, this is also 1. In this case, the output given will be equal to 1. Sorry. Here 0, 0, no matter if it is 1 or 0, the output will be equal to 0. So only in this state, it is on. Okay, so we have to find out the duty cycle. So duty cycle is, this is half cycle, half clock cycle by 2, and for this amount of time interval it is off. So it is on for T clock by 2 minus T clock by 5. If I find out, I will find out this time where it is on minus T clock by 5 divided by the total clock. Right, this is gonna give us the duty cycle percentage. So if you solve this, this will be 10, 5, T clock minus 2, T clock divided by T clock is equals to 3 by 10 into 100%, which is equals to 30%. So 30% is your correct answer. In this latch, the clock is given and input is also given in the form of clock, right? As we can see. So clock 1, clock 1 is like this, and clock 2 is delayed by some T clock by 5 value, right? So in this case, what we have to find out is output. Since D latch is transparent, whenever the value of 1 is there, it will give output as 1. So we have to find out when both the values are 1, when both the clocks are overlapping and value should be 1. Otherwise, when it is 0, it will giving the output as 0. So here it is 0, it is giving output as 0 only, right? In this case, we see that up to this time interval. So for this time interval, it is on. We can easily find out this T on time. The total time, this half is T clock, right? And this is off time. And this time is given as T clock by 5. So we can find out T clock. This is on time. This is on time. And divided by the total clock, that gonna give you duty cycle in percentage, right? Sorry. Okay, moving on to the next question. These type of question are like very mostly seen in these sequential circuit, because this question is for finding out what will the mod of the counter. What is mod? Mod basically is the value up to which value it counts, and after that mod value it will go back to its initial value. Suppose if I am saying that it is mod 5, it will count up to 5, 0, 1, 2, 3, 4, and it will go back to 0 again to the initial value after its counting up to 4 is completed. Right? If we start from 0 up to 4, that will become mod 5. If we start from 1 up to 5, that will become mod 5 counter. Means from 0 to 4 counting, or you can say from 1 to 5 counting. Both are same. For mod 5 counter, I am giving you just example. This is how we find out the mod value of any counter. Right? And what is this value? This is reset or clear thing. Okay. This is the value to give the reset that counter to initial value. If we don't reset it, whatever value of bit it is, it will count up to that. Right? We have to reset it eventually at some value if we want to terminate the counting at any particular value, be it 5, 6, 7 or whatever. Okay, so this is the concept for mod. Now here in the question it's given as some circuit is given. It is a 3-bit synchronous counter. Synchronous counter means all the clock given to the inside. So it is 3 bits. So basically three flip flops will be there. So the clock given to all the 3 flip flops will be same. The delay of the bubble NAND. Okay, so this has some delay of 2 nanosecond. And that of the counter is assumed to be 0. Counter delay is assumed to be 0. If the clock frequency is 1 gigahertz, the counter behaves as. So what value of mod it will give? So now this is a NAND. So it is reset is active low. Active low means whenever the output value is 0, it will reset itself to its initial state. Understood? It will reset its value to initial state. So what value of input should be there in order to give the value 0? So this is a NAND gate. So all the input should be 1 in order to give the output as 0. So it should be 1. It should be 1, and this is bubbled here. So it should be 0 because bubble will change it to 1, right? So it should be 1, 1 and 0. So this will be the value given as input to this NAND gate in order to make it value output as 0. That will reset this 3-bit synchronous counter. Understood? Now, this is what? This is 6. If I talk in a very easy way, so this is what is 1, 1, 0. It is 6. If it has no delay, no propagation delay, it should have been a mod 6 counter, because after 6 value it will reset its value to 0, 0, 0 again, right? So it will be counting up to 6. So it is a mod 6 counter. But no, here 2-second propagation delay is there. Now what is this? T clock will be equal to 1 by 1 gigahertz, which is equals to 1 nanosecond. So it will need 2 more clock cycle, because it will be giving output after 2 nanoseconds, right? So 2 more clock cycles, that means it will count again. That will be, it will count 7. It will, after plus 1 nanosecond time, it will again count 8 after plus 1 nanosecond time. So it will count up to 8. So it is mod 8 counter. So it will count up to 8 because of this delay present here. If there was no delay, it should be a mod 6 counter. If I draw the table for this, if I draw the table for you, what's happening here? So this is reset, or you can say AND value. Yeah, I will be writing here NAND output. Q2, Q1, Q0. Right. So it is ANDing not Q1 and Q2. So starting from 0, 0, 0, the value of NAND will be equal to 0. The value of, since it is 0, 0, 0, the value of NAND will be equal to 0. It will count here clock on first clock. Okay. Its value will be 0, 0, 0. The value of output of the NAND gate will be equal to 0, 0. So second clock, next clock will be there. So counting will increase. It is a counter. So it will count 0, 1, 2, 3, 4 and so on. Again, it will be 1. Second clock. It will count 2. Again, it will be 1. Third clock. It will count 3. It will be 1. Next clock. It is 4. It will count 4. Next clock. Fifth clock. It will count 5. Again, it's 1. Now, sixth. Its value will become 1, 1, 0. Now, here 1, 1, 0 is become like it's sixth counting. It's number 6. So, 1, 1, 0 we have received. But 1, 1, 0 is the required output which we are getting, but it will not stop because it has a delay of 2 nanoseconds, right? It will count one more. Okay, it will take here plus 1 nanosecond is taken. Okay, and it will count one more, that will be 1, 1, 1. So 1. It will again take plus 1 nanosecond. After this, it will reset itself. It will become 0, 0, 0. So what it is? 0 to 7. So it is mod 8 counter. Understood? By table you can see. But firstly, I told you very easy method. What you have to do is find out whatever input it will have to get in order to reset it. It should have 1, 1, 0 as input in order to reset it. But because of this 2 nanosecond delay, our clock is 1 nanosecond. Our clock time is 1 nanosecond. So basically it will need 2 more mods. Okay. Okay, question. Assume that all the digital gate circuit shown in the figure are ideal. The resistor is equals to 10 kilo ohms and supply voltage is 5 volts. The D flip-flop, D1, D2, D3, D4, D5 are initialized with logic. Logic is given 0, 1, 0, 1, 0 respectively. The clock has a 30% duty cycle. The average power dissipated in milliwatt in resistor should be. Okay. So how to tackle these kind of questions? So what is this? This is, we have to find out the power. Power, we easily know it is V square by R. Both the values are given. But in digital, what we should know? V square by R value is for DC or AC values, right? DC values basically. So it was always 1. But here we should get like waveform like this, either it is 0 or 1. So in order to send 0, there is no requirement for any power, right? There is no power consumed in order to send 0 bit because its value should be 0 volt. Whenever we are sending 1, it needs 5 volts or something amount of voltage or some amount of power in order to send it, right? So depend on the output, whatever output we are getting, we have to find out the power. So for digital, the power, total power become total T on, T clock will be a wrong thing to write, total time. Okay, whatever total time for output is taken, and in that time, whenever it is on, that will give you the power. Understood? For digital, in order to send 0, there is no requirement for power. Only whenever we are sending 1 bit, power will be needed. Just give me 1 minute. Right. So now this was the logic, right? Now this is something, what is this? This is a serial in, serial out, and this is a clock. Serial in, serial out type of register. and the input of this OR gate is equals to Q3 and Q5, right? Let's just draw the table for D1. Let me write it clock. So in these sequential circuit, you have to always draw the clock, because according to the clock, things are working. That's the only difference between a sequential and combinational. In combinational, there is no need to drive with the clock. Though no requirement for clock is there. D4, D5, and output Y is equals to Q3 plus Q5. These D1, D2 are, you can say, they are nothing but Q1. Okay, so clock, initially the values are given as 0, 1, 0, 1, 0. So output will be equal to, so there are no delays, right? They are ideal. Okay, no delays are there. So output will be Q3 plus Q5, 0 plus 0. So it will be 0. In next clock, this 0, this value Q5 will shift to Q1. So Q1 is nothing but equal to Q5 only. So it will shift like this. Okay. So this will come here and these all will shift like this. So 0, 1, 0, 1. Right. Again this 1 now here. Q3 plus Q5 is equals to 1. Because this is the output, right? This is the output we need. Because this output we need in order to find out the power. In this output, we have to find out the T on, and T is the total time after which it is repeating. Output is repeating itself. Okay, so in next clock cycle, it will be equal to 1 and other values will shift themselves. The value of Y will be equal to 0. Third clock, 0, 1, 0, 0, 1. Value will be 1. Fourth clock, 1, 0, 1, 0, 0. The value is 1. Fifth clock, it will become 0, 1, 0, 1, 0. The value will be 0. Now you can see here, same value is repeated after fifth clock pulse. Whatever value, initial value was there, it is repeated itself. It is repeating itself after fifth clock pulse, because we are getting the initial value 0, 1, 0, 1, 0, and the cycle will repeat itself after this. So output is given like this. So if I draw the output here, so output is 0 initially. For T, it is 1. 2T, it is 0, and it is 1 and 1, 3T and 5T, and it will repeat itself again and again after this, right? So total time is 5T, 5 clock pulses it will need. I am taking 1T as 1 clock pulse. This is your 1T, 1 clock pulse after 5 clock pulse, and it is on for 1, 2 and 3. So T on is equals to for 3 clock pulses. Now we got all the values in order to solve our power. So power value will be equal to V is given as 5, 10K, T on is 3T divided by 5T. This and this cancel out. This and this cancel out. 5 into 3, 15. So 15, 1.5 milliwatt. So 1.5 will be your correct answer. Understood? Okay. Moving on to the next question. Next question says that a pseudo random generator, so this is a random number generator, is shown. Okay, initially the value of output is equals to y2, y1, y2, y0 is set to be 111. The value of output y after 3 clock pulses. Very easy question. Okay, the initial values is given, right? Y is equals to y2, y1, y0, and they are saying that this is equals to 111 initially after 3 clock pulses. That means after 1, 2 and 3. So here y1 is equals to what? Y1 is equals to Q2, Y2 is equals to Q1, and Y0 is equals to Q0. How we are deriving these values of Q0, Q1 and Q2? So this is what? This is the XOR gate, and XOR is happening in between Q0 and Q1. So this is Q1 and this is Q0, and D2 is equals to D2, or you can say Q2 is equals to Q1 XOR Q0. So this is how we will be deriving our values. Okay, and this is what? This is shifting like this. So initially the values were 1, 1 and 1. So 1 XOR 1, 1 XOR 1 will be equal to what? 0, and 0 will come here and these values will shift. 0 XOR 1 will be equal to 1, 0, 1. 1 XOR 1 will be equal to 0, 1, 0. Right? So this will be the value. 0, 1, 0 will be the value after 3 clock cycles. I think I didn't make, yeah, right. We have to XOR these values. These are XORing. So 1 XOR 1 is 0, 1 XOR 1 is again 0, 0, 0 and 1. Here 0 XOR 1 is 1, 0 and 0. So this will be the value after third clock pulse. I XORed y2 and y0 by mistake, I'm sorry. So initially it was 111. What's happening? This value is coming to this. D1 is becoming this Q1 XOR Q0. I have written it wrong also. Okay, Q1 XOR Q0, and these values are shifting, right? So 1 XOR 1 is equals to 0, and these value are shifting. 1 XOR 1 is equals to 0, and these value will shift. 0 XOR 1 is equals to 1, and these value will shift. So the actual value is 1, 0, 0 will be the right answer. Okay, so question says that the circuit shown consists of a JK flip-flop, each with active low asynchronous reset. Now in this case, synchronous counter is not given. Synchronous means, see here, clock is applied to only first one. Others, this is clock signal, this is also clock signal. So for other JK flip-flops or other flip-flops, the clock is becoming the output of any other flip-flop. So this is asynchronous. Okay, the clock is not same to all the 3 flip-flops. So this is what asynchronous means. So reset output is there, RD. The counter corresponding to the circuit is, so we have to find out the mod of the value and what if it is a up counter or down counter. So in order to find out if it is a up counter or down counter, we have to check. So your clock is active low and the output is positive. So whenever this transition is there from positive to negative or negative to positive, the counter is always up counter. So what kind of counter this is? Up counter. So positive signal is given to a negative edge trigger clock. So that means the counter is up counter. Now we have to find out what will be the mod of this counter. Okay, in order to find out the mod, so this is given to reset. This value is given to reset, which will be resetting them to 0. So its value should be 0 because reset is active low. So reset should be equal to 0 in order to make the values of JK, all the 3 flip-flops will be equal to 0. So output should be equal to 0 and the values, input values for this Q1, this NAND gate, this is what? This is a NAND gate. The input values are Q2 and Q0, right? And we have to make the output 0. So what should be the value? So it should be Q0 equal to Q2 is equals to 1. If we achieve this, we will get output is equals to 0 and it will reset. So we'll start counting Q2, Q1 and Q0. It will up, it is the up counter clock 0 0 0 and this is output NAND Y. So it is equals to 1 in this case. First clock counting 1. This is again equal to 1. Second clock 1. Third clock 1. I'm writing fourth clock here. Fourth clock, it will count 4. It is 1 because Q0 and Q2 both should be equal to 1. We are not receiving, we haven't received any values till now. Fifth one, 1 0 1. Now here Q2 and Q0 will become equal to 1. And if they are becoming equal to 1 as the input of NAND gate, the output will become 0. Now what happened? It will reset all the values and come back to this initial state. Okay. Come back to the first state. So it is a mod 5 counter and it is a up counter. Clear? We can easily find out it directly from here also. So what value? So we need Q0. So we need this as 1 and this as 1. So it has two possible values. So which one will come first? Of course 0 will come first. So 1 0 1, that will be 5. So it will be mod 5 counter. Instead of making table, we can directly find it out like this. Right, up counter, I have told you how to find out up counter. If any opposite sign is given in an asynchronous type of counter, it will be up counter.